Find the equation of the tangent line for f of x equals 4x minus 3 squared times 1 minus 2x cubed at the point x equals 1. To find the equation of the tangent line, we need the x and y coordinates of the point. Right now we only have the x coordinate, so the first thing to do is find the corresponding y coordinate. And that's found by plugging the x coordinate into the function. We have 4x minus 3 squared and 1 minus 2x cubed. So the corresponding y coordinate to x equals 1 is y equals f of 1, which means 4 times 1 minus 3 squared times 1 minus 2 times 1, quantity cubed. 4 times 1 is 4, minus 3, then squared, and then 1 minus 2 times 1 is minus 2, and then cubed. 4 minus 3 is a 1, squared. 1 minus 2 is a negative 1, cubed. 1 squared is 1, negative 1 cubed. 3 negative 1s will become negative 1. And 1 times negative 1 is negative 1. So I have the point x coordinate of 1 and y coordinate of negative 1. The next thing we need for the equation of the tangent line is the slope. And the slope of the tangent line is the derivative. So we're going to be taking the derivative of f of x. F of x is a product of two functions. The derivative f prime of x will therefore make use of the product rule. We'll start with the derivative of the first. We'll bring its power down. Leave the inside alone. Subtract 1 from the power, then multiply by the derivative of the inside to complete the chain rule. All times the second left alone plus the first left alone times the derivative of the second will bring its power down, leave its inside alone, lower the power by 1, and then multiply by the derivative of the inside, which is a negative 2, to complete the chain rule. We only need to simplify this as much as needed to be able to plug in. So the next thing I'm going to do is just multiply the numbers. I have a 2 and a 4. Let's put those in the front here. So 8 times 4x minus 3 times 1 minus 2x cubed. And then for this next one we have a positive 3 and a negative 2. And altogether that'll be a negative 6. And then we have 4x minus 3 squared and 1 minus 2x squared. This can factor, but there's no need to factor. We might as well just plug in the 1. We really just need the value. The slope will be found by plugging in the x coordinate to the derivative. So this will be 8 times 4 times 1 minus 3 times 1 minus 2 times a 1 quantity cubed minus 6 times 4 times 1 minus 3 squared, and then 1 minus 2 times 1 squared. Four times 1 is 4. Negative 2 times 1 is negative 2. Likewise here. Now we can combine those numbers in the parentheses. So we have the slope will be 8 times 1 times negative 1 cubed minus 6 times 1 squared times negative 1 squared. So negative 1 cubed, 3 negative 1s will be negative 1. A 1 squared is a 1, and a negative 1 squared is also a 1. So it looks like we have a negative 8 minus a 6, which is a negative 14. So there's our slope. We have a point, we have a slope. We can set up the equation of the tangent line using the point-slope formula. it's going to be y minus the y-coordinate of the point, that's a -1 from up here, equals the slope, which is -14, times x minus the x-coordinate from up here, that's a 1. We're going to want to solve for y. That'll be called the slope-intercept form once you solve for it. We distribute the -14 in, and then a minus is a +1. So make that happen in the same step. If I distribute the -14, I have a -14x and then +14. And now let's subtract a 1 from both sides. And I have a -14x plus 13 to be the equation of the tangent line for that function at that point.